Opie plants 15 seeds in a potting mix. Experience has shown that for this type of seed the germination rate is approximately 85%. Let x be the random variable, the number of seeds that germinate. So in this particular case the random variable has been defined for us. What we can say is that x follows a binomial distribution with 15 trials and probability of success 0.85. We want the probability x is 10, so we could use the formula, but let's use the calculator. So I'm just going to clear everything. So interactive distribution discrete. It's a single value, so let's go for the PDF. We want 10. There were 15 trials because he's potted 15 seeds, and the probability of success was 0.85. Okay, so that's 0.0449. Correct to 4 decimal places. So 10 to 15, 10's not included, so actually this would be 11 if we do less than or equal to there. So we have a range of values here. So what we want to do is use the binomial CDF. So that's from 11 to 15. The number of trials is 15 and the probability of success is 0.85. So that is 0.9383. Correct to 4 decimal places. Now we want the expectation. Now we know from the notes that that's just n times p. So that's going to be 15 times 0.85. So 15 times 0.85 gives us 12.75. Remember, the expected value is like the mean, so it doesn't have to be a value that can actually be taken. We can only take whole numbers here. So SD of x, well, we know the variance is NPQ, so the standard deviation is root NPQ, which is the square root of 15 times 0.85 times the probability of failure, which would be 0.15. So square root of 15 times 0.85 times 0.15, and that gives us 1.383. If I give that to 3 decimal places. Now we want the probability that x is greater than or equal to 13, given that x is greater than or equal to 11. This is a conditional probability. So we need x is greater than or equal to 13 and x is greater than or equal to 11 divided by the probability that x is greater than or equal to 11. Now clearly the top, if it's greater than or equal to 13 and greater than or equal to 11, that's just the same as having greater than or equal to 13. So what do we need? We want, let's do the probability that x is greater than or equal to 13. So distribution discrete CDF, so that's 13, and then of course it goes up to 15 with 15 trials, and the success was 0.85. So that's going to be 0.604 and so on, divided by, do exactly the same thing with 11. In fact, let's just copy that, paste it here, just change that one there to 11, and that gives us 0.938 and so on. And so finally we just want that one divided by that one, and that gives us 0.6440 if we go to 4 decimal places.